Well, g'day, Max here again. Welcome back to the shop. Well, we're coming to the closing stages of our lathe repair. So we're up to the stage where we have to make the way wipers. So in order to do that, I need a couple of bits of tooling for the bridgeport. So I need to make a slitting saw holder. Well, I've got to make 3 of them because I've got 3 different size slitting saws. So we'll get cracking into that. So I'm going to have to make a ring gauge for the R8 taper, so we get all our taper spot on, and then we can hook into that. Before we do that, we'll just do a quick alignment on the tailstock. This is I call it the cheats method. It's a quick shortcut method, so I'll explain how I do that. So yeah, so it's really still hot here in Perth, 7:30 in the evening at the moment. I'm just looking at the thermometer. We're on 35 degrees, so it's cooled off about 6 degrees to what it was earlier on this afternoon. So that's about 90, well at the moment that's 95 in the Fahrenheit scale. Yeah, 35 degrees C. So our temperature's slowly dropping down. We've got a string of days of 40, 41 degrees. So that's around 105, 106 in the Fahrenheit scale. So we've got a few bushfires happening around Perth at the moment just from all the hot weather. So yeah, you get that, I suppose, of the dry land. So anyway, let's crack on with this tailstock alignment. Okay, so what we're going to do, we've got a short bit of centerless ground bar. So the centers in it can't be relied on because it's been centerless ground. Now, there's centers in these because they've been done on a production type environment. They're a very shallow center. They don't have the skinny bit inside as you'd get if you drilled it with a standard center drill. So the centers are compromised on this. So what I've done, I've marked the spot there, just a little circle. So we'll put him in the lathe. So if we bring our indicator along, we'll go make sure our indicator's on centre. So the tip of our indicator is in that circle that we marked. So what I'll do now is I'll zero the indicator just using the cross slide. Okay, so we're spot on 0 there. So we'll come back to the other end of the bar, and we're a thou under. Oh, sorry, yeah, we're a thou that way too far, the tailstock. So what I'll do, to verify that, we'll rotate the bar 180 degrees. Stick our centre back in. Now we're back in alignment on our same little blue circle that we marked. So we're measuring the bar in exact same spot in regards to the reference to where the centre is on the bar as we were at that end. And yeah, the bar's got to go that way 1 thou. Well, that's pretty good because this tailstock, we just plonked it back together and we're only a thou out. So we'll just swing you around so you can see the tailstock adjustment. Okay, so I'm just going to slacken off very slightly. Just want very light pressure on the tailstock lock. So if we've got to go that way, we've got to slacken off on the adjuster on this side. It's already slack. And I'm just finger tightening on the lock screws at the rear. Now this one here, we nip this one up. No, I'm going the wrong way. We slacken that one. It always catches you out which way to go on these tailstocks. Okay, we're on 0. Come around the other side. Okay, we're on 0. I'll nip up our locks at the back. slacken our lever off and give it a good, she's nice and tight. Okay, so we're bang on 0 on our dial there. So we'll just verify all of that again. We'll just flip our bar around. Okay, we're on 0 there. We're on 0 there. This is actually reading 0 all the way across this. I know the ground bar is perfectly parallel 1 inch. Yeah, no, we're on 0 there. So that's a good quick way to do it. I don't have, if I was to turn up a piece of bar between centres, I'll be starting off right off centre. So when I go to drill my centre hole, we don't know where we're going to be in regards to tailstock alignment. So this is a quick, easy preliminary method. Now you can spend the time now and make a test bar, turn a test bar, but personally at this stage with this lathe I'm not going to do that. This will be good enough, because when this lathe gets into the new shop, I'll make a new base for it and that will be bolted to the ground. Now I know this bed has about a thou 2 twist in it. Now I cannot get that out unless it's bolted down. So the other thing against turning and testing your lathe with a bar you've got to be very careful of. You can see, you watch some people do it. They'll take a big bit of aluminium bar and take a very light cut. Well, that's going to give you, that will get you spot on centre, but when you're actually machining a part, you'll find that you get a lot of flex and give and everything, and you're going to have to readjust your tailstock depending on the size of the part and the amount of depth of cut you're taking, because it will make a difference. So that's why every now and then you've got to tweak your tailstock depending on what part you're turning. So if that makes sense. But this is well close enough for anything that we'll be doing. If I'm turning a longer shaft and I'm getting a taper, then I will readjust accordingly. So, okay, well let's get our chuck back on, piece of material in, and start making this ring gauge. Okay, we've whacked our 4-jaw on. There's a good reason why we're doing this job in the 4-jaw, and that's because I've had this lathe in bits for that long. I can't find my 3-jaw. It's around here somewhere. But so what I picked up, a bit of scrap. It must have been an old pin or something like that. It's a couple of drilled holes in the end. So interesting, been playing around with these hardness test files that I got the other week, and so I'm thinking this is a bit of 4140. Now this is the 40 Rockwell file. So if it's skating across it, it's not biting in, but it's on the verge of biting into it. So we're in the vicinity of 40 Rockwell, maybe just under 40 Rockwell, I think. Yeah. So that'll be good. This is a lot better than mild steel. So we'll get this clocked up. Okay, put a clock on it. It's running within 1,000, so that's close enough for what we need to achieve. Looks like our tool's way above centre. Okay. Alright, I've got to re-plug the lathe in. I've had it all unplugged since the repairs, so I'll go and plug the lathe in and bring you back. Well, here we go. First chips. We'll get this face back till we're at the bottom of these drilled holes. We'll probably drill it, bore it for the taper. We might even grind the taper on the ID, I think. So, see how we go. So our tool is still a smidgen above centre. Just drop him down a fraction. Try that. Better. Depth of cuts. This one's 80. That makes it grunt, doesn't it? Okay, we've still got a little divot there, so we'll take another 60 will do it. That's good, beautiful finish on that. Okay, we'll get set up now with a centre drill and we'll hog out the inside. Chuck a bit of flood coolant on this just to keep it cool. I do have to change this coolant. I'm going to switch over to, I'm looking at switching to synthetic, so. we'll get our part parted off, then we'll flip it over, get it faced, and then we'll do the taper in it. See how the lathe goes with the parting tool. It should be alright, it's been alright in the past, so probably try running that a little bit quicker, I think. Not that quick though. Looks like the night shift's coming to take over. I don't know what that is, I've never seen one like that before. So we've got our ring gauge slug parted off now. So I've already done a corner radius on this side here. So we'll flip it over, we'll face off this side and we'll do a corner radius on here. Then we'll do the taper. Good. Alright, we'll finish that one off with a form tool. Just a matter of getting the form tool just in the right position so the edges of the tool don't catch the faces and the OD of the part. And we'll slow the lathe down a bit for this one. I'll swing you around to get a better shot. Okay, we'll clean that one up with a bit of emery paper and a file and should be sweet. Now, we're about to do our setup for the taper. Now, if there's ever a time where your tool needs to be on centre and it's critical, it's when you do a taper. So, I've got a height gauge here, and I've taken a reading from the top of the part. Then I've measured the diameter of the part, divided that by 2, which that gave me 1.104. So I've subtracted the 1.104 from the height of the top of the part, which comes to 3.459. So that's what I've set the vernier height gauge to. So the underside of the height gauge is spot on centre. So then we just bring that over our tool, and we just use that to adjust up our tool. If your tool isn't on height, on centre when you're doing a taper, you're not going to get a true taper. I don't know, I think you might get a slight curve. And because this has to be a very accurate taper, because we're doing a ring, it is a ring gauge, and this will gauge all of our R8 tapers that we build in the future. I'll just get the magnifying glass to verify that. Okay, we're spot on there. So now we can start cutting our taper. So what we'll do is we'll swing the compound around and we'll do the calculations for that. The angle for an R8 taper, the included angle is 16.85 degrees. So we have to swing our compound exactly 8.425 degrees. So we'll get that happening. Okay, well this episode is going to be too long to fit into one video, so I'll have to break it down to 2, maybe 3 parts for this ring. As grinding, as we mentioned before, I'd like to grind the ID of the taper ring. The reason I'd like to do that is because we are using bluing compound to test on a machine on a turn surface. It's just going to give us that much smoother surface finish inside. Now what I don't want to do is start polishing it with emery paper and distort, possibly get some high and low spots, a bit of unevenness in the bore, because this will be used as a proper gauge to test. We've got a lot of R8 tapers to do on fit and future tooling, so this will be used to test all of them, and I want them all the same. So anyway, that's enough of that twaddle. So in case I don't get the other video out before Christmas, which I might be pushed, take it easy, Merry Christmas, and I hope all goes well. Cheers.